Hello everyone, I'd like to introduce my friend Dr. Viv Robinson, who's going to talk to you about some general properties of that particles would have if they were made from doubly looping photons. Over to you, Viv.
Thanks, John. This is the first in a series of presentations where I want to take your mind on a journey through space and time. This journey covers topics from the smallest subatomic particles to the universe's large-scale structure. I start out explaining the basic structure of all matter particles and how those structures give them their properties. That is followed by the structures of protons, electrons, neutrons, neutrinos, and some of the elementary particles. Knowing them makes it easier to explain nuclear binding and the structure and properties of all nuclei. Along the way, I'll cover what are regarded as some of the most complex topics in the physical world. And these include, but are not limited to, Einstein's special and general relativity theories, subatomic particle physics, nuclear physics, and quantum mechanics. Then I will deal with gravity and the vastness of the universe. Yeah, look, these topics are large. I mean, each really needs a lecture series in its own right to adequately cover it. The best I can do is give a brief introduction, enough to get started. I mean, that brevity does mean that some concepts may be poorly expressed or open to misinterpretation. And the alternative is a long series of detailed presentations on each topic, at the end of which many people will have lost the plot. And don't worry about the complexities involved with them. In my presentation, there's nothing complex about any of these topics, including Einstein's relativity theories. And things happen for a physical reason. It's those reasons that I will explain to you. When the physics is understood, it is easy to visualize what is happening. Then use mathematics to work out the magnitude of that happening. If the calculations match observation, a theory has some merit. So, some mathematics is required to understand the universe. I've tried to keep this as simple as possible. Throughout this work, there's nothing more complex than some high school Newtonian mechanics, Pythagoras' theorem, a bit of trigonometry like sine and cos, and some calculus like the integral of 1 over r squared dr or e to the ln r, and other such simplicities. I mean, really, that is all that is needed, even for those who want to extend Einstein's gravity calculations from his general relativity theory. The fundamental premise of what follows is that all individual matter particles are made of photons of the appropriate energy, making 2 complete revolutions within their wavelength. And this may raise a few eyebrows and request some answers to the questions. However, I'm sure the first question is, what is a photon? That's a very good question, the answer to which necessitates an in-depth mathematical discussion. The choice is between giving an in-depth presentation that many may not be able to follow, or apply the results of that presentation to show how this model does work. That will make it simple to understand the intricacies of the universe in a continuum from the smallest subatomic particles to its large-scale structure. Then, when all that is understood, photon experts give their presentation on photons to an enthused audience, thus showing that the rest of the university's stories is well-founded. Quicycle has taken the latter approach. The second question is, what possible proof is there of that premise? Well, it comes in 2 parts. The first is the experimental result from all particle accelerators like CERN's Large Hadron Collider or Brookhaven's National Lab particle accelerators. They all start out with charged particles, protons or electrons, and accelerate them to high speeds by adding photons to them. When energies of many TeV have been achieved, these are then smashed into other particles to get a shower of particles and photons. Now, when everything has died down, all that is left are the original particles, plus possibly a few neutrino and antineutrino pairs that can't be detected. All other particles have decayed to photons. They, along with the photons emitted at the same time, have long since been absorbed as heat. I mean, nothing else has ever been detected. That is the best experimental evidence that everything is made of photons. Apart from photons, the only stable particles ever detected are electrons, protons, neutrons, and neutrinos. The second is, how well do the predictions under this model match observation? That is what my series of presentations is all about. In my opinion, and that of others, that match extends from the smallest subatomic particles to the large-scale structure of the universe. And this is what we're going to see. Look, some attempts were made to explain particles as standing electromagnetic waves. Those models went nowhere. Their authors were not able to match particle properties. It is different with this toroidal or rotating photon model. This all originates out of work on the electrons. Historically, the first attempt at describing an electron was Sir Arthur Compton. In 1918, he wrote that the electron was a ring of electricity subject to rotation. The dimensions he attributed to that ring were over 10 times larger than the following model. Dr. John Williamson and Martin van der Mark were the first to publish the idea that an electron was a toroidal photon, one that made 2 revolutions within its wavelength. They were able to make some useful predictions, some of which I incorporate in this presentation. Other authors, including myself, concentrated electrons as toroidal or rotating photons. But there's a lot more to the universe than electrons. I moved on to look at the properties that all particles would have if composed of rotating or toroidal photons. A direct result of all particles being made from photons is they should have many features in common. And this presentation deals with that commonality. Some of the following mathematics is made easier because of Dr. Williamson's work. He sets out in the mathematical terms under which linear and rotating photons can interchange. He will answer questions relating to the mathematical support for the model in a future presentation. This is what is meant by a photon making 2 revolutions per wavelength. It is the simplest possible presentation, and it's just intended to show some important features. When they are established, some of the complexities can be introduced. Diagram A shows a quarter wavelength being equivalent to half a circumference. In half a wavelength at B, it has made 1 complete revolution. In 3/4 of a wavelength, it's made 1.5 revolutions. And finally, in a full wavelength at D, it's made 2 revolutions. Its diameter is its wavelength, lambda, divided by 2 pi. And the colors indicate phases, not inside or outside properties. Now, how does this match up experimentally? Well, experimentally, electrons, protons, neutrons, and neutrinos, as well as their antiparticles, all have measured spin of half h bar. So we'll work on the hypothesis, originally forwarded by Uhlenbeck and Gauss-Schmidt in 1926, that electrons have internal angular momentum given by I omega equals half h bar. Now, but for a rotating hoop, which is what a rotating photon is, I equals mr squared. Omega equals c over r, and that equals 4 pi c over lambda. Multiply both sides by omega and substitute gives mr squared times c over r, c squared over r squared equals h over 4 pi times 4 pi c over lambda. Well, that just simplifies to mc squared equals hc over lambda equals h nu equals E. Well, that is the first important feature of this model. It shows the relationship between energy and mass given by E equals mc squared. Under this model, energy is a photon traveling at c in a straight line. Mass is the same photon making 2 revolutions within its wavelength. Through E equals mc squared, mass was often referred to as frozen energy. From this derivation, it is easy to see that mass is confined, not frozen energy. That confinement is the photon making 2 revolutions a wavelength. Each and every individual particle composed of a confined photon making 2 revolutions within its wavelength will have angular momentum equals half h bar. That is the property that quantum mechanics refers to as spin. And that should also take care of whether or not photons have mass. They don't have rest mass because they don't exist at rest. Later in this presentation, I will show the physics behind the special relativity corrections derived by Lorentz, Einstein, and others, as well as deriving another correction. And why are there 2 rotations per wavelength and not 1 or 3 or 2 wavelengths per rotation? 2 rotations per wavelength means that the electric and magnetic fields overlap and can reinforce each other. All other combinations mix fields and won't give stability. That's the physical reason. Those seeking a theoretical explanation are referred to papers by Dr. Williamson and Vandermark on Is the Electron a Photon of Toroidal Topology and A New Linear Theory of Light and Matter. From E equals mc squared, we get hc over lambda equals mc squared. But r equals lambda over 4 pi. Substituting gives mc squared equals hc over 4 pi r. Solving gives r equals h bar over 2 mc. That will be a radius in all particles. That also answers a dilemma mentioned by Stephen Hawking. A half h bar structure had to go around twice to turn round once. That explains why it is so. The photon has to make 2 revolutions for the particle to go around once, which means for the particle to exist. Now, that was the briefest presentation of a photon making 2 revolutions per wavelength. A little more detail is required. The first thing to know is that they are rotating photons, not rotating electromagnetic waves. Photons have a beginning and an end. Now, that is schematically illustrated here. Diagrams A and C show schematic representations of photons. Details of these will be filled in later in this Quicycle series. Both show oblique views of a photon that has a sine curve oscillation of the electric E and magnetic B fields. Polarities are indicated by color and sign. Each is 1 wavelength long, that being the extent of a sine curve traversing through 360 degrees. Physically, the conversion of linear photons to rotating photons occurs in one of 2 principal waves. Beams of photons of the appropriate energy are aimed at each other. When they collide, their linear momentum is converted to angular momentum and a particle-antiparticle pair is formed. The other method is to use beams of photons of the appropriate energy and direct them out to heavy nuclei. In both situations, the photon's linear trajectory is stopped. If it is not absorbed, it must conserve its energy and momentum. That is done by the photons splitting in 2 and changing their linear momentum into angular momentum. Conservation of angular momentum means that the 2 must rotate in opposite directions. The ease with which that occurs in photons of the appropriate energy suggests an inherently stable state is reached. Dr. Williamson will discuss that state later, but right now I want to consider what will happen to just one of the 2 photons. The black arrows in A and C represent the axis traveling at the speed c in a straight line. Diagram E represents the same axis traveling through 2 cycles over that wavelength. It is intended to show that while the axes and hence the photons make 2 revolutions per wavelength, the ends do not join to form a continuous wave. I repeat, the structure is a rotating photon, not a rotating electromagnetic wave. The difference is that waves are continuous, photons are discrete entities. Diagrams A and C both have a curved blue arrow. That indicates the direction the photon will bend in this representation. Diagram A, being representative of a circularly polarized photon, has the electric field and magnetic field on the same quadrants in both half wavelengths. Diagram B shows that when it curves through 2 revolutions, one electric field, positive in this illustration, will always be on the outside of the looped structure. The other field will be internal. The south and north magnetic poles will always point in the same direction. The result is a charged particle with one electric polarity on the outside and a magnetic field always pointing in the same direction. Contrast with that with diagrams C and D. They represent a plane polarized photon with a different polarity on the outside and the alternating magnetic field through its center. That represents a neutral particle, one that has no net external charge. An important feature here is that charged and neutral particles have a different polarization state in the primary photon. That's the one that rotates to produce the particle. Another feature to note is that it is the angular momentum of the rotating photon that generates the charge. Unlock that angular momentum, for example, by getting a particle and antiparticle to annihilate each other by releasing their angular momentum, and the charge disappears. The reason why every individual charged particle always has the same charge is because their angular momentum is always the same at half h bar. At this stage, it must be pointed out that when such half h bar angular momentum is established, its conservation is a very powerful mechanism to keep it rotating. But that is only half the angular momentum of a circularly polarized photon, which is h bar. A particle composed of a circularly polarized rotating photon has conservation of its half h bar spin angular momentum, the h bar intrinsic rotation of the photon, and the overlapping and reinforcing like electric and magnetic fields to keep it together. A particle composed of a plane polarized photon has only the conservation of its half h bar spin angular momentum to keep it stable. It has overlapping opposing electric charge and magnetic fields. That makes charged particles inherently more stable than neutral ones. Associated with that is the electric charge that generates the electric field originates at the rotating photon's circumference. That will also be discussed by Dr. Williamson later. An important feature to note from the rotation mechanism is that photons are emitted and absorbed at the circumference of the axis of the rotating photon and in its plane of rotation. Also, electric charge isn't uniform and three-dimensional throughout the particle. It is planar and emitted in 2 dimensions from the rotating photon's axis of rotation. From there, charge spreads into the 3rd dimension. Its source is the photons emitted at the radius of curvature of the rotating photon that is the particle. Their initial direction is outward from that radius. The magnetic field is perpendicular to the plane of rotation and gives particles their 3rd dimension. From observation, the magnetic field associated with an individual particle, its Bohr magnetron, mu b, is E h bar over 2mc. Under this model, a particle's Bohr magnetron is its charge multiplied by its radius. I use that throughout this study. Also, to indicate a charged particle in general, I will use the notation in diagram C. The black line represents a rotating photon. The arrow heads its direction of rotation. The blue arrows represent the emission and absorption of photons to indicate that it is charged. An important feature about all of this is that all particles are entirely electromagnetic in nature. Nowhere is there a feature that could be considered a solid particle, perhaps like a billiard ball object. Everything is electromagnetic in origin. There is nothing else. By the end of the 20th century, physicists had noticed that it was difficult to tell the difference between particles and photons on the smallest scale. Erdmann wrote a book he called The Photonic Structure of Photons. In reality, he was writing about the photonic structure of partons. It is photons that generate particles, not the other way around. Now I would like to talk a little bit about a particle's spin, parity, and chirality. In this model, they are all related. Spin is angular momentum of the rotating photon that is the particle. Parity is simply particle and antiparticle pairs. Chirality relates to the direction of a particle's properties. It is usually referred to as either left-handed or right-handed. I have already shown that a particle's spin is angular momentum, I omega equals half h bar, produced by a photon rotating at instantaneous speed c twice around its wavelength. Spin is quantized because the photon can only rotate in one of two ways, and we've got clockwise or anti-clockwise when viewed end-on. Look at diagrams A and H. They are both anti-clockwise rotation with a north pole represented by the dot pointing out of a page. Now look at G and form your right hand into the same shape. Twist your hand until your thumb is pointing at you. It is now pointing in the direction of the North Pole, and your fingers are pointing in the anti-clockwise direction of rotation. In this convention, they represented a positive charge, say a positron. Now look at B. With your right hand fingers bent in the same appearance, point your thumb at the screen. It is still pointing in the direction of the North Pole because the South Pole is represented by the crosses sticking out of the page. Your fingers are pointing in the direction of the photon's rotation. Diagrams A, B, and H are examples of right-handed chirality. In this convention, they represent a positively charged particle. Now look at A and B. They are the only two ways a right-handed chirality particle can spin with respect to its direction of its magnetic field. But they are nothing more than other side of the page images of the same structure. The spin of a particle depends upon the direction from which it is viewed. Now look at D and F. They both have the North Pole pointing out of the page and rotate in the clockwise direction. Now use your left hand. Point your thumb and bend your fingers as shown in diagram E. Now twist your hand so that your thumb points towards you. Your thumb is now pointing in the North Pole direction and your fingers are pointing in the direction the photon rotates, as shown in D and F. That is what is called left-handed chirality. In this convention, it gives rise to negatively charged particles, such as an electron. Now look at C and point your thumb at the screen. It will point in the direction of the North Pole, and your fingers will point in the direction of the photon's rotation. It still has a negative charge, but it has opposite spin to D and F. Spin is the angular momentum of the rotating photon. It is quantized because a photon can only rotate in one of two ways, clockwise or anti-clockwise. The different states of spin are just the other side of the page images of the same particle. A particle's chirality, its direction of rotation of the photon with respect to the polarity of the magnetic field, determines the charge of the particle. If you look at B and C, you'll see they are mirror images of each other. So are F and H and A and D. They are particle-antiparticle pairs that define parity. The charge of a particle is determined by the direction of a photon's rotation with respect to the magnetic field it generates. Particles with the same charge have the same chirality, and particles of different charge obviously have different chirality. An antiparticle is a mirror image of its particle. When a particle and its antiparticle meet, they unlock each other's angular momentum. The rotating photon now becomes two linear photons, releasing E equals mc squared. Those photons travel in opposite direction to conserve linear momentum. Before I move on, there are some things I would like to explain about spin for those who want to work in the field of quantum computing and other spin-related properties. Consider the situation of a particle, right-handed chirality, approaching two observers, 1 and 2. In zone A, both observers will detect it as spinning anti-clockwise. As it enters zone B, observer 1 could detect it as spinning clockwise, while observer 2 will still detect it as spinning anti-clockwise. In zone C, both observers will detect it as spinning clockwise. Both will give it a digital value, e.g. up or down, or 0 and 1, as they have no idea what they are measuring. In my opinion, that confusion could be overcome if their descriptions were changed to spin CW for clockwise and AC for anti-clockwise. Like that was introduced to illustrate a particular situation. An observer in zone B will have no prior knowledge of what is the spin of the particle. Only when it's measured could its spin be determined. That has led some to think of spin superposition. The particle can have both states of spin at once, and the actual one is selected when the observation is made. And that's an excuse because they have no idea what is happening. That brings us to quantum mechanics and spooky action at a distance. Quantum entanglement occurs when like particles are brought sufficiently close together that they adopt the same properties. This illustration shows two electrons with their magnetic fields attracting each other without much interference from their like negative charges. Separating them requires an action that will break their bonds, reversing the spin of one of them. And if it doesn't reverse that spin, they'll stay entangled. Those spins, which are now opposite, go on to be measured in the normal way. And if you don't break their entanglement, you can't separate them. And if you don't entangle them in the first place, the result will be random. That's not some hidden variable. Photons behave like waves, like particles, because they are waves that have a limited extent. It is now time to show why particles behave like waves. Before starting this presentation, I would like to point out that others have derived expressions for the de Broglie wave, including de Broglie himself. This presentation gives a physical explanation of its origins from this rotating photon model of matter. To do that, consider the energy components. The total energy E of a particle of rest mass m0 and momentum p is given by E squared equals p squared c squared plus m0 squared c to the fourth. Because a particle is entirely electromagnetic, its rest energy is given by E0 equals h nu naught, where nu naught is its rest frequency. Its total energy at velocity v is given by ev squared equals mv squared c to the fourth, and that equals h nu v all squared, where nu v is its frequency at velocity v. Combining those two equations gives h nu squared equals h nu naught squared plus p squared c squared. Well, that's Pythagoras' theorem. All terms are energy. The base is rest energy. The hypotenuse is total energy. The arrow is the energy in the direction of travel. Its magnitude is the kinetic energy of the component that's available to react with the environment. It is given by E sine theta equals h nu v sine theta equals pc equals h nu ke, where nu ke is the frequency component of a particle's energy in its direction of motion. It's the only component of energy available to interact with the environment. Substituting nu ke equals c over lambda ke gives lambda ke, where lambda ke is the rotating photon's electromagnetic field wavelength in its direction of travel, gives pc equals hc over lambda ke, or lambda ke equals hp, the de Broglie wavelength. As the particle moves, it automatically generates a de Broglie wavelength in the electromagnetic field. In that manner, a slowly moving, lightweight particle, like an electron, can generate quite a large electromagnetic disturbance, making it look as if it is a large particle. The reality is that its electromagnetic field automatically adjusts to its moving conditions. There's not a beat frequency between moving and rest particles. It's a frequency generated by the particle's own electromagnetic field as it moves, and it will travel with the particle. We cannot conclude a discussion on general properties of matter until we can show why their structure makes them subject to Einstein's special relativity corrections when they move. Not to do so would be to say special relativity corrections are a mathematical imposition on all matter with no physical reason. That's not the way things work. The special relativity corrections have been derived by others. Lorentz derived the corrections for length and time. Einstein also derived those corrections and showed that mass also changed with velocity by the same correction factor. Those derivations were mathematically based and difficult to follow. In this model, I show the rotating photon provides a physical reason for those corrections and presents them in a simple yet accurate manner. To do that, I must start out with some representations of how a rotating photon structure can move. This summarizes the two ways by which such a structure can move. They can move either parallel to its plane of rotation, as in A, or perpendicular to it, as in B. All other motions are combinations of both. Option A is complex, and I didn't calculate it. I will use option B. If others want to calculate intermediate orientations, fine. Diagram C shows end-on 1, oblique 2, and side-on 3 representations of the circumference of a rotating photon at rest. It's either a circle, ellipse, or straight line. Diagrams D1, 2, and 3, respectively, show the same views of it moving. A particle structure is a rotating photon, not a rotating wave. A photon has a beginning and an end. As it moves in this direction, it must spiral through space because its end comes after its beginning. Irrespective of the trajectory or path the photon travels, it always moves at a speed of light, c. Its travel becomes an exercise in Pythagoras' theorem with the photon's trajectory as the hypotenuse. In rest time t, to make one rotation, a photon will travel the distance ct, given by 2 pi rv squared plus vt squared equals ct squared. That can be rewritten as 2 pi rv squared plus vt squared over 2 pi r naught squared equals ct squared over 2 pi r naught squared, which, since 2 pi r naught equals ct, that becomes 2 pi rv squared over 2 pi r naught squared plus vt squared over ct squared equals 1. Rearranging, that gives rv squared over r naught squared plus v squared over c squared equals 1, for which one solution is rv equals r naught times the square root of 1 minus v squared over c squared. The radius of a rotating photon, that is the particle, decreases with the square root of 1 minus v squared over c squared as its speed increases. As a particle of this type moves, its angular momentum, I omega equals half h bar, stays the same. The rotational contribution of c to angular momentum is now only c sine theta. The rest angular momentum is the same as the moving particle's angular momentum, which becomes I omega equals m naught r naught squared times c over r naught equals mv rv squared times c sine theta over rv equals half h bar. Here, m naught and r naught and mv and rv are the rest mass and radius and velocity mass and radius respectively. That simplifies to m naught r naught equals mv rv sine theta. Rearranging gives mv equals m naught r naught over rv sine theta, which, since sine theta equals rv over r naught, becomes mv equals m naught times r naught squared over rv squared. Substituting rv equals r naught times the square root of 1 minus v squared over c squared gives mv equals m naught over 1 minus v squared over c squared. That would make a particle's mass increase faster than the energy put into it. Something's wrong. To find out what that something is, we have to look at how a photon would travel through space. Now, it would corkscrew its way through space, somewhat as illustrated below. This particle is shown making 2 double rotations as it moves. A side-on view of that corkscrew action is indicated by the black line in the upper diagram. As shown in the last slide, it physically can't do that because its mass would increase too much. The only way it can do that is to slow down its rotation. Now, that poses a problem that the photon is now no longer traveling at c, and that can't occur either. So at the same time, it has to develop a forward slip motion while it is rotating more slowly. The forward slip motion is indicated by the green arrows. It is not that the photons slip sideways. It can't do that. The spirals are elongated in the particle's direction of travel, as shown by the blue lines. And this is shown in the spirals below. The black line elongated. They show no separate slip motion. The top illustration is useful to show what happens when the rotating photon moves. I can't show its rotation slowing down. What this shows is that when the photon slows down, it must develop a forward slip motion to maintain its speed at c. That means it doesn't have to corkscrew or spiral as many revolutions to make its way between 2 points. The black arrows show how far it is spiraled. The blue arrows represent how far it has traveled. The difference, the green arrows, is how much space has been foreshortened in that direction of travel. That is what physically happens to cause time to slow down and distance to become shorter when a particle composed of a rotating photon moves. The only way that can occur physically and keep the mass increase equal to the energy input increase is if all are adjusted by the correction factor, the square root of 1 minus v squared over c squared. That's the reason why mass, length, and time change with velocity. It is mathematically and physically due to the constant speed of light being the hypotenuse of a right-angled triangle. Pythagoras' theorem remains the same whether it's on a plain piece of paper or wrapped around a cylinder. That is what gives the relativistic corrections. Mass, which was m over 1 minus v squared over c squared, becomes m over the square root of 1 minus v squared over c squared. Time, t at velocity v, becomes tv equals t naught over 1 minus v squared, the square root of 1 minus v squared over c squared. The length LV traveled by a particle becomes LV equals L naught times the square root of 1 minus v squared over c squared. The other relativistic correction here was the change of a particle's radius with velocity. Even if it wasn't derived theoretically, it would be determined from the calculated radius of r equals h bar over 2mc because of the increase of mass with velocity. That reduction of radius doesn't mean to say that space collapses in all 3 dimensions. Although the dimensions of individual particles decrease, lateral dimensions are maintained by electric charge. They remain unaffected. There is one feature to note about the derivation that must be pointed out again. Those special relativity corrections depend upon the rotating photons spiraling their way through space. This is illustrated in this diagram. As they spiral through space, they generate its electric field. The magnetic field leads its travel. Later in this series, I will show that that has been observed and does represent how particles travel. This lower diagram shows another feature about particles and antiparticles. Diagram A illustrates an electron moving to the right. Diagram B illustrates a positron moving to the left. Reverse the direction of the arrow on the electron and it will indicate an electron moving to the left, going backwards in time. It will be exactly the image of the positron. This model demonstrates that a particle moving forward in time is indistinguishable from a particle moving backwards in time. It is now time to summarize the properties of the rotating photon particles under this model. All particles are composed of photons of the appropriate energy making 2 revolutions within their wavelength. There is no solid anything that constitutes the particle. They all have a mass m equals h nu over c squared and a spin, that is angular momentum, I omega equals half h bar. Any particle with a different spin is a combination of 2 or more spin half particles. Now, the basic radius of a particle is r equals h bar over 2mc. Electric charge is a property of the rotating photon. It is not something stuck on mathematically because there's no other explanation. Remove the spin and the charge disappears. A particle's electric field is generated at the circumference of the plane of rotation of the photon that constitutes it. The charge field spreads into the third dimension away from this circumference. The charge polarity of a particle is determined by the chilarity of its rotation with respect to the particle's magnetic field. Rotating circularly polarized photons give rise to charged particles. Rotating plane polarized photons give rise to neutral particles. A particle's magnetic field is perpendicular to the plane of the photon's rotation. The Bohr magneton of a particle is its charge multiplied by its radius, i.e. μb equals Eh bar over 2mc. Whenever a particle moves through space, its rotating photon circumference spirals its way through that space. A moving particle automatically generates its de Broglie wavelength, lambda equals h over p. As the particle moves, it is automatically subjected to Einstein's special relativity corrections of mass, length, and time, as well as its radius diminishing, all with the correction factor, the square root of 1 minus v squared over c squared. Now this one's what some may find unusual, but as the speed of a particle increases, its mass increases, its charge remains the same, and its magnetic moment decreases. Now you know why. Spin is quantized because a photon can only rotate in one of two ways with respect to its axis of rotation. An antiparticle is a mirror image of a particle. When a particle and antiparticle meet, they unlock each other's angular momentum, and the two rotating photons travel away from each other as linear photons. The relationship E equals mc squared between energy and mass is that energy is the photon traveling in a straight line. Mass is the same photon making two revolutions within its wavelength. There are no other forms of particles that are not composed of rotating photons. All of those are general properties of all particles under this rotating or toroidal photon model of structure. Aspects of those are common properties of all particles. Their origins are a natural consequence of the rotating photon's toroidal structure, and there's nothing difficult about any of them. What was just presented was a brief introduction to the general properties of particles made from photons of the appropriate energy making two revolutions per wavelength. Along the way, it covered properties like spin, charge, magnetic moment, mass, dimensions, chirality, parity, and duality through the de Broglie wavelength. It also covered Einstein's special relativity corrections, including E equals mc squared. Many of those properties will be familiar to physicists. That simple model unites the properties of subatomic particles with Einstein's special relativity corrections. It is hoped that puts an end to the idea that photons have no mass because of the special relativity corrections. The special relativity corrections do not apply to photons because it is their mass and constant velocity that causes particles to be subjected to them. Photons without mass and point particles with properties attached mathematically are dead-end theories. Thank you.